Hello, Assalamualaikum. We are from Group 8 and we will present to you about haloalkane, Chapter 7. So this is our group members. So I will introduce to you one by one. So we have Nur Elisha Farhana binti Romzi, and we have Nabila Aisha binti Muhammad Nasir, and me myself, Putri Husnina binti Ahmad Hazmi. So let's move on to Task 1, Chapter 7, haloalkane. So this is the question for task 8. Haloalkane with molecular formula C4H9Cl has 4 isomers, which is A, B, C and D. And we have to give IPAC names and classification for these isomers. And then we have to arrange these isomers in ascending order of their reactivity respect to SN1 reaction. And we have to give the explanation respectively. And then we have to write the reaction equation involved for the reaction of the most reactive isomer among A, B and C. And with respect to SN1 reaction, we will undergo with potassium cyanide in ethanol under reflux. And then we have to show the reaction of the mechanism. Okay, I will explain to you part by part from this question. So let's move on by giving the IPAC names and classification for isomer A, B and C. As you can see here, we have the haloalkane molecular formula C4H9Cl. To see it more clearly, we can classify it like this. We have isomer A, isomer B, isomer C. To give IPAC name, I think it will be easier for us to see if we draw the structure. So this is the structure for isomer A, isomer B and isomer C. As we have learned in class, when giving IPAC name, we have to start from the longest carbon chain. So from isomer A, the carbon chains start from here, 1, 2, 3. And the substituent we have here is Cl and CH3, which both of it attached to the carbon number 2. And when giving IPAC name, we have to give it in alphabetical order. So the IPAC name for isomer A will be 2-chloro-2-methylpropane. For the classification, we need to look at the carbon atom that attach directly to the haloalkane. From there, we can determine the classification of the isomer by the alkyl group. As we see here, the carbon atom that attach directly to the haloalkane is carbon number 2. So next we have to look at to the alkyl group. So we have 1, 2, 3. So the classification will be tertiary haloalkane. For isomer B, IPAC name, carbon atom will start from here, 1, 2, 3, 4. The substituent we have here is Cl, which attached to the carbon number 1. So the IPAC name will be 1-chlorobutane. The classification will be primary haloalkane because alkyl group that attached to the carbon that directly attached to the haloalkane is only one here. So the classification will be primary haloalkane. As for isomer C, the IPAC name, carbon chain will start from here, 1, 2, 3, 4. The substituent we have here is Cl at the carbon number 2, so the IPAC name will be 2-chlorobutane. As for the classification, the answer is secondary haloalkane because we look at from the carbon number 2, the alkyl group we have here is 1, 2. So that is why the classification for isomer C is secondary haloalkane. Okay, let's move on to the reactivity for the isomer A, B, and C. From the classification from isomer A, B, and C, we can indicate their reactivity based on the classification. So the most reactive isomer is A, followed by C and B. Why? So this is the explanation. Isomer A is the most reactive compared to isomer B and C. Because isomer A is tertiary haloalkane, as the carbon atom holding chlorine is attached directly to 3 alkyl groups, whereas isomer C is secondary haloalkane and isomer B is a primary haloalkane. Thus, isomer A is the most reactive towards SN1 and is the most stable. So let's move on to the reaction mechanism. Okay, let's move on to reaction mechanism. From question, the question asks us to show the SN1 mechanism of the most reactive isomer. Since we have known that the reactive isomer is isomer A, so isomer A will be used for the reaction mechanism. SN1 mechanism involved with 2 steps. So isomer A, which is 2-chloro-2-methylpropane, will undergo reaction with potassium cyanide. Ethanol and reflux will produce this product, which is the last product you will get is here. So let's move on to step 1, which is the formation of carbocation. The bond between the carbon and halogen will undergo heterolytic bond fission, and the reaction will undergo slowly, and the result will be carbocation intermediate and halide ion. The carbon cation, which is positively charged, and halide ion is negatively charged. So this product, which is the carbocation intermediate, will be used for the step 2. In step 2, nucleophilic attach on the carbocation. The nucleophile, which is cyanide, will form a bond with the carbocation, which is here. Cyanide will form a bond with the carbocation, and the reaction will undergo fast, and it will produce the last product, which is here. The product will be 2-cyano-2-methylpropane.
Alright, so we continue with the next question. And so basically, when we get this type of question, we need to first read all this question truly so that we are able to determine the reaction of the structure. So let's go and look how we are able to solve this question. Alright, firstly we look at the structure of H. It is given that structure H is C8H18, which is the product of D when react with sodium metal and ether. So basically this is the Woods reaction, and it also states that H possesses 2 tertiary carbon and symmetric alkane. So when we draw the structure H, we must make sure that it have 2 tertiary carbon. Basically the first tertiary carbon is here and the second tertiary carbon is here. So basically this is a symmetry alkene. So and then we go to the next structure. As we know that structure H is Woods reaction, and Woods reaction is the reaction of haloalkane with alkyl metal, usually sodium, to synthesize longer alkene. So by knowing that, we can know that structure D is like this. And the IUPAC name of structure D is 1-chloro-2-methyl-propane. So how we know that it is Cl that attached to the structure D? Then we goes on to the question that state that the structure E is alkyl magnesium chloride as product when D react with magnesium in an anhydrous ether. So basically, this is the structure is an alkyl magnesium chloride, which is this MgCl is attached with the alkyl. So by doing this, we know that this it is correct that Cl is attached here. And then we go to the next structure, which is structure F. Structure F is the product of E when which is hydrolyzed, which is C4H10. So basically, it is the substitution nucleophilic substitution hydrolysis. So the magnesium chloride is substituted with H ion here. So and then we go to the next structure, which is structure G. It is stated that structure G is the process of elimination when structure D react with sodium hydroxide and ethanol and under reflux. So this will produce alkene, and Caesar is used to determine the major product. So basically, we can see here that there is a carbon double bond here when we do elimination process. And then the last one is structure I, which is the hydrolysis of structure D with aqueous sodium and under reflux. So when we do this reaction, basically we will get alcohol. So structure I is alcohol, which is 2-methyl propanol. Alright, so for the next task is task 2, inert component. So I will pass this slide to Nabila.
Functional group carboxylic acid, chosen plant date palm, Quran verses. With it he produces for you corn, olive, date palms, grapes, and every kind of fruit. Rarely this is a sign for those who give talk. One of the components in date palm is benzoic acid. Fresh dates are rich in phenolic antioxidants. Specifically, dates have been shown to contain benzoic acid, cinnamic acid, flavonoid glycosidase, and ester, flavanthiol, and proanthocyanidins, which all belong to the phenolic compound. So, this is the structure of benzoic acid. Composition of the plant: 1 serving or 1 average size stick. It has 20 calories, 0.03 grams fat, 0.17 grams protein, 5.33 grams carbohydrate, 4.5 grams sugar, 0.6 grams dietary fiber, 0.012 milligrams vitamin B6, and 0.07 milligrams iron. And the benefit of the plants: it's a high in phenolic antioxidant which scavenge free radicals and protect the health of cells and reduce inflammation. It is one of a good source of dietary fiber, with over half a gram per dried fruit, for curbing appetite and regulating blood sugar and digestion. Carotenoids are proven to promote heart health and may also reduce the risk of eye-related disorders. Preparation of benzoic acid. Benzoic acid can be prepared from oxidized toluene with hot alkaline potassium permanganate. The oxidation is observed when purple color turns to colorless.
Alright, so basically this is our references when we're doing our assignment. And that's all from us. Thank you for watching this video.